So now we're going to install what's called an IDE or Integrated Development Environment, which will allow us to write C programs and run them on our computer. So just search for CodeBlocks, and I want you to go to this website. Over here we're going to Downloads, and in here choose your operating system. I'm using Windows, and we have to download the setup that contains MingW. We must have MingW in order to be able to run our programs. So now we click on one of these links. I'm going for this one. So this website will open and we have to wait. And now the download should start. I already downloaded CodeBlocks, so after you do that, just go to the download and now double click on it. And now just proceed with the installation. So next, I agree, next, and install. I already installed CodeBlocks, and after you do that, you'll find a shortcut on the desktop for CodeBlocks. If you double click on it, CodeBlocks is going to open. So in order to start, we have to create a new project. So we press here or we go to File, New Project. Right here we choose Console Application, we press Go, and we choose the C language, then Next, and now we have to name our project. So I'm going to call it Section 1.1, and here we will choose where we're going to save our projects. So I'm going to put them in a new folder on my desktop called C. And now we press Next, and because we downloaded MingW, all this should be filled by default, and now we press Finish. And now our C project is all set up, and if we press here, then here, this code will appear. This is a C program that prints Hello World. So let's build and run it. I'm going to press here, and we're going to see this output. When we made the project, we chose Console Application, and in this case, this is our console. So now that we're sure everything is working correctly, we're ready to start learning C. See you in the next video. So in this video, I want to talk about this code. So over here, I'm using the number sign followed by include. So this means that I want to use something inside this file, alright? So I want to include, and in angle brackets, I'm saying standard input output and standard library .h and .h. This .h means that these files are header files, and a header file is basically a file that contains some C code that is already written and we can use it. Alright? So for example, this printf, we know that it prints hello world on screen, but I don't care about this right now. What's important is that if we right click on it and press find declaration of printf, you will see that standard input output.h automatically opens, and here we have the declaration of printf. So in order to be able to use printf in this file, I'm including the standard input output header file over here. So then I'm going to use something from inside this file over here. For example, printf. Alright? So to keep things simple, you will include these two files every time in your program because you will always use them. Now, this over here is called a function. Let me tell you about the parts of the function. First of all, it has a type. So the type of this function is an integer, and we type it int. So an integer is a number without a decimal point. So for example, 0, 1, -2, -3, okay? Any number without a decimal point. Then we put a space and the name of the function. So the name of this function is main, and this is a special name because this function is the main function inside any C program. Then we put some parentheses, we will talk about them later, and then we have braces, and inside the braces we have the code of the function. Basically, a function is a group of code. Alright? So this main function has two sentences, right? This sentence ends with a semicolon, and this sentence ends with a semicolon. So whenever you see something that ends with a semicolon, it is called a statement or an instruction, and it's basically a sentence that makes some action. So for example, printf prints something, right? So this is an action. Now return 0, let's talk about it. I'm going to press over here, build and run. So this basically will transform this code into a program that my computer can run, and it will automatically run it. So press on it, and here you go. This is the result of printf, it printed something, and this over here is the result of return 0. So the process returns 0, so the program returns 0. Alright, so let me close this and change this to be 1, for example. Now build and run again and have a look. Now we have process returned 1. Alright, so since the type of main is an integer, we can tell it to give us or return an integer, and that is using the return, and after it we put the integer that we want, and usually we put return 0 to indicate that when we run our program and it finishes, everything works perfectly without errors. So let me build and run. So now we see process returned 0. This indicates that our program ran successfully and it has no errors. Now if we have an error, we will see something different than return 0. We may see a long negative number, okay? I don't know. But what's important is that whenever we see process returned 0, we will know that our program ran successfully without errors. But let me tell you something. Sometimes we see return 0, and even if we see it, we still have some problems in our program, but don't worry, we will talk about that later. What I want you to know right now is whenever we see return 0, we can suppose that everything is okay. Alright? And later on, we will see the importance of this return statement or instruction whenever we start making functions of our own. Alright? Now, one more thing to say about the main function. As I said, it is the main function in a C program. So, whenever I build and run the program, this will create a program and run it, right? So, when I run the program, the first thing I do, I come to this function and start executing the instructions inside it. So later on, when we make functions of our own, we will use these functions from inside the main function, okay? And don't worry, everything will be clear. But now just have the idea. Now, one more thing to talk about. Suppose you want to say something about the program. So for example, this program prints something on screen, okay? So let's try to build and run the program and we have an error. And this is basically because we are typing something that C does not understand. This is a human language and this is not a C code. So this will cause an error. So to be able to write something in a human language, we have to make it a comment. So it is not considered a part of the code. So we put 2 forward slashes, and to make it a little bit bold in code blocks, we put 3 forward slashes. Now this over here is a comment and it will be ignored. It's not a part of the code. So build and run, and now the program works, okay? So this is a single line comment. So if we type something over here, it is not a comment. So to make a multi-line comment, put forward slash star star forward slash. So whatever we put over here will be a comment. So have a look. Everything is in gray. So everything is a comment. And to make it a little bit bold, put more stars over here. So now if I build and run the program works and these are ignored. Alright? So this is it about comments. So whenever you want to write something and explain and put some details, use comments. So this is it, and I'll see you in the next video. So here is the code from the previous video, and I will remove these comments. Alright? I don't want them. Now I want to talk about the build process. So we have a C code over here, right? When we press build and run, a program is created and we run it on our computer. Okay? So this code is written in the C programming language. So to be able to run it on our computer, we must convert this code into a program that the computer can understand, so we can run it on the computer. So you remember the compiler that I told you about? This compiler is responsible for transforming this code from the C language to a language that the computer can understand. Okay? So let me show you this. This is my project folder. Over here I have a folder called OBJ. This is short for object. Open it and open this, and over here you will see main.o. So the main.c file contains our code in the C programming language. Then the compiler converts this to something that the computer can understand, and this thing is this file over here. This is an object file. It contains a code that the computer understands. Alright? So this is the job of the compiler. It compiles the code from a high language, which is in this case the C programming language, to a low language which the computer understands. So the high language a human can understand, and the low language the computer can understand. Okay? Now this object file, double click on it, and as you can see, I cannot run it on the computer. It's not an application. So the compiler does not make an application. Let me go back over here, open this bin, it is short for binary. Open it, and this, and over here I have an application. So this is the program that can actually run on my computer. Let me tell you what happens. First of all, the compiler transforms the C code into object files, okay? Then something called a linker links the object files with other files that we are using in our program. For example, we saw these header files previously, right? We are using them inside the main.c file. So the linker combines the object file that the compiler created, which is the main.o file, with the header files that we are using. And when everything is linked together, we get this application. And this is the program that can run on the computer. Now let me show you this. Double click on this, and as you can see, it is opening and closing very fast. So let me tell you why. In CodeBlocks, if we try to build and run this, it runs and it stays over here, right? And this is because we are running it inside CodeBlocks. So over here, I'm going to add something, system, and put double quotes, and inside put pause. So now I'm going to build a new program and run it. So build and run. And now as you can see, we have this press any key to continue. So press anything, and now the program ends. So now I have a new program that pauses before it exits. So now if you try to run it, this is the new program. Double click and have a look. It runs and then it waits for me to end it. So now if I press something, it will close. Alright? So later on, I might not use system pause because I'll be running the program from inside CodeBlocks. But if you want to run your programs from over here, you should add this system pause. Okay? So the build process is two steps. First, the compiler works and then the linker. Okay? So have a look at this button. It builds our program and then runs it. But this button only builds the program. So this executable file will be created. Then this button runs the executable file. So for example, if I make some changes over here and I don't build the program, let's try to run it. Over here we see the current program working. Okay, we did not create a new program. So let's create a new program. So build, and now this file over here changed. So if I run it over here, we can see the new program working. And this button over here builds and runs the program in the same time. Alright, so this is all about the build process. I know it's boring, but it's important to know what happens whenever we create programs. Okay, so this is it, and I'll see you in the next video. So let's say that I have some information and I want to store this information. Okay, we all know that our computer has something called memory or RAM. Okay, when we run our program, it is loaded into the RAM and it works over there. So if we want to store some information for our program, we can store it in the memory. So in order to store anything, we need a place in the memory to store data in. So this place is called a variable. To make a variable in the memory, I'm going to put a comment over here. First of all, we specify the type. So if I want to store a number, I should choose a type for a number, for example, integer. After the type, I leave a space and then I put the name of this variable. So imagine you have a box and you put a label on the box. Okay, so this name is a label. So I'm going to call this num, for example. And now I just put a semicolon. So right now I have a box called num, and let's say it is of type int. So this box stores integers, and this is basically a variable. Okay, this is a declaration of the variable. So I made a box in the memory to store an integer in. This is declaration. Now we're going to dive in. Let me remove this because I forgot it. Okay, so over here we have int i1. So now I have a variable i1. This code over here, I want you to ignore it. I'm just printing the value of i1. So all these printfs for this video, pretend that they are not here. Okay, I'm going to run our program in order to see the values of the variables. So first of all, we declared i1 and I printed its value, and as you can see there is 74 inside i1. This is an interesting thing because we didn't put anything inside i1 and it already contains a number. So keep that in mind. Now let's say I want to put a number inside i1. So simply I'll say that I1 is equal to 5. This is called the assignment operator. It takes the value on the right and it puts it in the variable on the left. So now this 74 is going to be erased and 5 will replace it. So I printed I1 and as you can see we have 5. Okay, now I do another assignment. So I1 is equal to -3. So we say goodbye for 5 and when I printed I1 we get -3. Okay, so as we said, I1 stores integers, so numbers without decimal points. Over here I'm trying to put 3.5 inside I1. Okay, I printed I1 and as you can see there is 3. So this 0.5 is lost. What's happening exactly? This is casting. 3.5 is converted to an integer, so the decimal point and all the numbers after the decimal point are lost. So we get 3. So as you can see, this type of casting happened automatically. Later on we're going to do casting manually. Perfect. Now I want to show you something. I have this line of code commented, so if I want to remove the comment I press Ctrl+Shift+X and I get rid of the comment. So what I'm saying here, int I1 is equal to 2. Okay, let me try to build the program. So I want to transform this code into a program that the computer can run. Okay, just build. You'll see that I get an error, and this error is because we already declared I1 and over here we are declaring it again. So this is a problem. Regarding this equal to, just pretend it's not there. Okay, just like this. Let's try to build and we also have the same error. So I'm going to comment this line of code, press Ctrl+Shift+C and it is commented, and now let's build and the error is gone. So let me run this again. As I said, we have 74 over here. This is garbage, so it's always better to initialize our variables. So what's initialization? Initialization is giving our variables some value when we declare them. So over here, let me say int I1 is equal to 0. So this is initialization. And now I'm pretty sure that I1 contains 0 and nothing else. So it's a good thing to always initialize variables. Okay, so this now is called initialization. Okay, now we want to store a variable with a decimal point. So we're going to use a type called double, and we also have another type called float which does the same thing, but double has more precision than float, so always use doubles. So the same thing, I'm declaring a variable called d1 of type double and I'm initializing it to be equal to 3.5 and I'm printing it, and as you can see d1 is equal to 3.5 and it automatically prints 6 digits after the decimal point. Okay, now if I say that d1 is equal to 0, 0 will be casted or converted to a double, which is 0.0 in this case, and we have it over here. And this over here is an example for a float called f1, so I initialize it to be equal to 3.7 and I printed it and it is over here. Perfect. Now let's suppose we want to store a character. Look at your keyboard, the letters you see. Suppose you want to store any of them inside a variable. We have a type called char, it is short for character. So I'm making a character called C and I'm initializing it to be equal to A. A very important note over here that A is put inside single quotes, as you can see. I didn't put A in double quotes. A in double quotes is a string, and that is a group of characters or a text. We'll see an example in a little bit. But the point here is to always use single quotes with characters. This is very important. So let me build and run this, and I'm printing this character and we see A. So now if you can pause the video and go take a look at the ASCII table. Google ASCII table and you'll see a table of characters and numbers. I want you to look for the letter A, big A. You will see that the decimal number of this A is 65. So look what we're doing right now. We're saying that C is equal to 65. So because C is a character, 65 is going to be converted to a character. Just like when we had an integer and we converted it to a double, and when we had a double and we converted it to an integer. It's the same idea. So this 65 will be converted to a character, and in this case this character is A according to the ASCII table. So I printed C, and as you can see we have A. And now I made an integer called code and I set it equal to the character A. The same thing will happen. A as a character will be casted to an integer, and according to the ASCII table, when I printed code, as you can see we have 65. Now we're going to talk about booleans. A boolean represents true and false. True is always represented by 1, number 1, and false is always represented by 0. So here is the type underscore big B OOL. So I'm making a boolean variable called B and I set it to be equal to 0. 0 means false, okay? So I printed B and I see 0 perfectly. Now I set B to be equal to 1 and printed it and we see 1. Now's the interesting thing. I set B to be equal to 2 and I printed it and I also see 1. And also I set B to be equal to -1 and printed it and also I see 1. So what I want you to take from this, 0 is the only thing that gives me false and everything else is true. So all of these are ones and only 0 gives me 0. Now we can use some keywords such as true and false, and in order to do so we have to include stdbool.h. As you can see, I already included it over here. So I'm setting B to be equal to false and I'm printing it, and we have B is equal to 0. Then I'm saying B is equal to true, then I printed it and we have B is equal to 1. Perfect. Now we're going to see a string or a text or a group of characters. You don't have to fully understand it, I just want to give you an overview, okay? So a string is a group of characters. So as before, we have this type characters and I'm calling it name. And these brackets, I'm saying that I want a group of characters. And in this group of characters, I want to store this group of characters. I put it in double quotes. So since I put this in double quotes, C understands that this is a string and it knows how to deal with it. So now when I print this name, as you can see, we have this text or string or group of characters printed perfectly. These are the main types, and we're going to see more types as we go through the course. For now, this is pretty much enough. I want to show you an example of how we can know how much a variable can hold. You don't have to memorize it, you can always Google how much can I store inside an integer or inside a double, but it's a good thing to know. So again, I don't need you to understand any of this, I'm just giving you an idea. First of all, I'm getting the number of bytes of an integer and I'm storing it inside x. Then I'm printing x. So the number of bytes of an integer is 4 bytes. So whenever we want to make a variable of type integer, we are saying that we want 4 bytes inside the memory for this integer. Now we have to calculate the number of bits. 1 byte is 8 bits. So 4 bytes equals 4 times 8 bits, which is 32 bits. And now, to know how much we can store inside an integer, we just calculate 2 power 32. So 2 power 32 is this number over here. So we can store this much inside an integer. Note that this number is divided between the positive numbers and the negative numbers. And I'm also going to put a link in this lecture resources, and you will see a table containing the data types and how much can we store in each data type, and many more details if you're interested. But for me, this is pretty enough right now. So I'll see you in the next video. So let's have a look over here. I have an integer x initialized to be equal to 10 and double y initialized to be equal to 3.0. I'm assigning x to be equal to y. So what's going to happen over here? We're going to calculate the right side, which is in this case y, and y is equal to 3. Then we're going to store this 3 in x. So 3.0 will be casted to be equal to 3, then we put it inside x because x is an integer. I'm going to build and run the program, and I printed x and y, and as we can see, x is equal to 3 and y is equal to 3.0. Okay, so what if I want this x to be constant? so that its value can be changed. So what I have to do is to add this keyword before the declaration or initialization of x. So now if we try to build the program, we're going to get an error, and this error says that x is a read-only variable, which means that its value can be changed, and we're trying to assign something to it. So now x is a constant. And by the way, if I didn't initialize this, let me comment this line of code, and now let me run the program. As you can see, x contains garbage, and this garbage is constant. We can't change it. So what's the point of making a constant if we don't want to initialize it? So always when you want to make a constant, initialize it to the value that you want. So for example, this x is a constant that is equal to 5. Now I know that x has the value that I want, not some garbage, and this value is constant. Okay, these are declared constants. As you can see, we are using the normal declaration or initialization, and we're adding the const keyword. Now we're going to have a look at defined constants. So what I want you to do is to come over here, add a number sign, and type define. Then hit space, and now write the name of the constant. Let's say I want to make a constant called pi. And now put a space, and now we put the value of this constant. So let's say it is 3.14. So now I have a constant called pi and has a value 3.14, and I can use it like any other variable. So for example, I can say y is equal to pi. Now let's run the program, and as you can see, y is now equal to 3.14. One more thing I want to mention in this video is the address of a variable. So this is a variable in the memory, and also y is a variable in the memory. And each variable has an address, its unique address. So in order to find this address, we have to use the AND before the variable name. So for example, I'm printing AND y. Let me build and run this. And as you can see, I get this number. This is actually the address of the variable y in the memory, and it is printed as an integer. Addresses are in hexadecimal. So I'm going to show you the address of y in hexadecimal. So build and run. And here is the address of y in hexadecimal. If you don't know what is hexadecimal, just Google hexadecimal and have a look. And that's it for this video. So we have this variable x, which is equal to 3, and this double y, which is equal to 3.5. Let's say we want to print the values of x and y. Then we are going to use a function which is called printf. So what's a function? It is a group of code. And someone made this function that prints something. So in between these parentheses, we have to tell printf what we want to print. And the printf takes strings, so it takes something between double quotes. So if I want to print hello, I can say printf hello. Now build and run, and as you can see, we see this printed. So I'm giving printf a string to print. I can't give it something like this, it will give me an error, as you can see. Now we know that printf takes a string. Let's say we want to print the value of x. We can't just say printf x like this, because x in this case is a string, and if we build and run this, we're going to see x. So whenever we want to print a value, we have to use what's called format specifiers. So for example, let's suppose I want to print x equals. So this prints x equals perfectly. Now I want to print the value of x. So I have to use the format specifier for an integer, because x is an integer. There are many format specifiers for each type, but one of the format specifiers of an integer is %d. So we put this %d between the double quotes. So now printf knows that I want to print x equals, then I want to print a value of a variable of type integer. So now I want to tell printf which variable I want to print. So in order to do so, after the double quotes, we put a comma, and now we specify the name of the variable we want to print. So in this case, I want to print x. Now let me build and run this, and as you can see, x equals space was printed perfectly as it is, and then this %d was replaced by the value of x, which is 3. So this is it. printf knows that this %d is for this variable x and it prints its value. Now let's suppose we want to print the value of y. So I'm going to use printf and I will print y equals, and now I want to use the format specifier of a double, and one of the format specifiers of a double is %lf. So now I want to tell printf which double I want to print. So in this case I want to print y. So let me build and run this, and as you can see x is equal to 3 and y is equal to 3.5. Perfect. I want to say one thing, they are printed on the same line. So in order to get to a new line, we add this \n. This is a special character that gets me to a new line. So let's build and run this now, and as you can see we printed x equals 3, so we printed everything up until the \n. Then the \n got me to a new line, and now we are executing this printf, so we printed y equals 3.5 on a new line perfectly. Okay, so now I want to show you how to print multiple variables in the same printf. So I want to print the value of x and I want to get to a new line, and right here I will say that I want to print the value of y. So I want to print y equals, and now I will use the format specifier for the double, which is %lf, and now I want to tell printf that I want to print y. So after x I put a comma, then I put y. So printf knows that the first format specifier is the first variable and the second one is for the second variable. So let me build and run this, and we get the same output as before. So we printed this, then we got to a new line, then we printed this. Now let me show you this. Let's put y over here and let's put x over here. So we're saying that the %d is the format specifier of y and %lf is the format specifier of x. Let me now build and run this, and as you can see the values were not printed. So we have to be specific on which format specifiers we are using. We cannot use the format specifiers of an integer to print a double, and also we cannot use the format specifier of a double to print an integer, and so on. So now we have these more variables and I want to print them. So let's start. I want to get to a new line and I want to print this f. So I will say f equals, and now I have to use the format specifier for a float, which is %f. And now I will get to a new line and I want to print this character c. So I will say c equals, and I will use %c as a format specifier, and that's it. Now I want to print a boolean. So as we know, a boolean has two values, 0 or 1. So we can use the format specifier of an integer to print a boolean. So let's say b equals %d. And now we want to print this string, so I will get to a new line and I will say name equals, and I will use %s as a format specifier for a string, and that's it. Now I have to tell printf which variables I want to print. So the first one is x, the second one is y, and the one after that is my float f, then my character c, then my boolean b, then my variable name. Now let's build and run this. And as you can see, x equals 3, y equals 3.5, f 5.6, c, a, b 1 because it's true, and name is printed perfectly. Now we know that this prints 6 digits automatically. So I want to show you something. Let's say that y is equal to 3.589, and I want to print y rounded up until 2 decimal points. So over here I will type 0.2. Now let's build and run this. I press F9 in order to build and run without pressing on this button over here. So as you can see, y equals 3.59. So this number was rounded and we get 3.59. If I want to round up until 1 decimal point, so I use 0.1, so build and run, and we get 3.6 as you can see. Okay, so one more example. Let's say printf, your name is, I want to print the string, so I say name, build and run, and it is over here, hello, your name is Ali Badran. And if I want to get to a new line, I put \n over here, build and run, and here we go. So this is it for printf. I will remove this example over here, and now let's talk about scanf. Let's say we want to take input from the user. So for example, Let's make a double age and initialize it to 0. And now we want to ask the user for his age. So printf enter your age. And now we want to take this information from the user. So we have to use the function scanf. This function also takes a string in double quotes, but for example we can't write enter your age. This gives us an error. We have to use printf in order to make an output, and scanf is only used to take input. So over here I have to tell scanf what I want to read or take input. So I want to take a double, so I use the format specifier of a double, which is %lf. And now I have to specify in which variable I want to store this information. So I want to store it inside age. But this here gives me an error. Scanf takes the format specifiers and the address of the variable I want to store the information in. So over here we have to give it and age, and now this is correct. So now let's do this. For example, your age is, and we want to print a double, so %lf, and this double is age. So let's build and run this. So enter your age, let's say 20.5, and now we press enter, and as you can see your age is 20.5. So now we're starting to take input from the user and printing it. So this is very good. So now I want to show you something. Let's say I have int x equals 0 and double y equals 0. And now I want to take x and y from the user. So I can say I want to read an integer, and also I want to read a double, and I want to store the integer in the address of x, and I want to store the double in the address of y. And after this I want to print x equals %d and y equals %lf, and I want to print x and y. Perfect. Let's build and run this. So now it's waiting for me to enter x and y. We can do this in two ways. We can enter x, for example 4, and press enter, and now y, for example 4.5, and press enter. As you can see, x is equal to 4 and y is equal to 4.5. Perfect. The other way is to enter them on the same line separated by a space. So for example 3 and 8.9. So press enter, and as you can see x equals 3, y equal 8.9. So now I want to show you something interesting. And a very important note, and it's obvious, since we are reading %d first, we have to enter an integer first, and then we enter the double. The order is important. So let's say we try to enter 4.5 inside x. You might think that 4.5 will be casted to 4, and then this 4 will be put inside x. Let's press enter and see what will happen. As you can see, x is equal to 4 and y is equal to 0.5. So why is that? Let's imagine that we will move along this number and we will store what we can inside x. So first of all, we are at 4. So 4 is an integer, so we can store 4 inside x, and we store it. Now we reach this point. So point cannot be stored inside x because x is an integer. So this 0.5 remains with us. Now we are going to read a double. So we have this 0.5, so we don't ask the user to give us input. So this 0.5 is actually 0.5. So as you can see, 0.5 was stored inside y, and the program did not wait for us to enter y. So let me build and run this again, and for example let me type 4.5 and 2.3. Let's press enter, and as you can see 4 is inside x and 0.5 is inside y, and 2.3 was ignored. And the program doesn't wait for me to enter y. So this is a good thing to know. So I want to show you another thing. I'm reading x and y in separate scanfs. Let me build and run this, and let's enter 4.5, and we still have the same problem. So as I said before, the 0.5 was still with us. So now I'm going to get rid of this 0.5. So I'm going to use a function called fflush, and I'm going to give it standard input. So the 0.5 was still in the standard input. So I'm flushing this standard input. So I'm getting rid of the 0.5. So let me build and run this, and now let me type 4.5 and press enter. And as you can see, the program is still waiting for me to enter y, because there is nothing with us. We got rid of the 0.5. So now I can enter 2.3 and press enter, and as you can see x is equal to 4 and y is equal to 2.3 perfectly. What happened? 4 is stored inside x and 0.5 was still with us. Then we got rid of it and then we store 2.3 inside y. Perfect. So now I'm going to make a character c and I will put it equal to 0. So 0 will be casted to a character and put inside c. I think that 0 in the ASCII table is null. Null means that it is nothing. Okay. So now let me comment this flush. So Ctrl Shift C and let me read this character. So %c and I want to store it inside the variable c. Now over here I'm going to print c. So %c and over here c. And y will stay the same. So let's build and run this. I'm asked to enter a character. So let's say A and now I press enter. And now let's enter 4.5 and press enter. And as you can see, everything went correct. Let me put the cursor on this line, press Alt and press the up arrow. So I'm going to move this line of code. So now I'm reading Y, then I'm reading this character. Let me build and run this. So 4.5, press enter. And as you can see, it didn't wait for me to enter C. And over here, we printed C. And as you can see, we got to a new line. So what happened? When we typed 4.5, we pressed enter. So this enter was inside stdin. So just as before, because we have it, the program didn't wait for us in order to fill C, and it stored this new line inside C. And you can see it over here, we got to a new line. So in order to fix this, all you have to do is to flush stdin after we read Y. So now let's build and run this. And now let me enter 4.5. And as you can see, it waits for me to enter C. So let's say A, press enter, and here you go. C is equal to A and Y is equal to 4.5. So there is one other way in order to fix this problem. Let me comment this line of code, and before this %c, just add a space. Now if we build and run the program, let's enter 4.5 and A, and everything works correctly. Just a note before we move on. Suppose we are reading two variables in this scanf, and one of these variables is a character. So there must be a space over here. Just like in this case, we put a space to fix the problem. Here is the same thing. But suppose that we are reading an integer, this space can be removed and we have no problem. But in the case of %c, we must put this space. Okay. So one more thing. For those who are interested on how to make a string and read it, continue watching this video. So I'm going to make a variable called name, and it is a group of characters, and I'm going to say that it has maximum 50 characters. Now when I want to read it, I'm going to use %s, and now I'm going to say where I want to store this string. Okay, so what you're thinking of is that we put the address of name, but actually this is not correct, and you don't have to understand this right now. Just take the idea. This name is the address. This is not a normal variable. This is different from C and Y and X. So put this in your mind. This name is the address. So in order to fill this string, we have to give the address, which is in this case name. Okay, let me remove this and let me print name %s, and I will print name. So let me build and run this, and let's say this is my string CSA. Now I press enter, and as you can see, CSA was stored in name perfectly. One more example. If you try to enter more than one word, so it is separated by a space, so let's press enter, you will see that you get only the first word. We're going to talk about this later. So this is it for this video. It's a lot of information, and I hope that you get a lot from it. So I'll see you in the next video.